All right, so this is lesson 4.3, and here's your warm-up. So take a few minutes, copy it down, put it on your bell work paper so that you have it complete to turn in next week, and come on back and we'll talk about it. All right, so if you were using your X's and O's system like we learned in the last unit, I could say these are both X's, which means since they're both an X, they have to be congruent to each other. So your equation looks like this. And then you can go ahead and solve for X. Same thing here. Those are vertical angles, so they should be set equal to each other. And finally, on the diagonal, those are also both equal to each other, because if I was using my X's and O's system, they are both an X again, so they are equal to each other as well. So all three of those were set equal to each other. Contents information, please take a moment and pause the video and transfer that into your table of contents, and then the corresponding page in your notebook and write down your objective. All right, so today we're going to talk a little bit about congruent shapes. Congruent shapes have the same size and the same shape. So make sure that you're getting this information right here in your notebook. Information on the right is optional. You can put that in if you want, but keep in mind that we will be talking a lot over the next few months about similar and congruent shapes. So the circles in the green on the right are congruent. They're the same shape and size. However, the triangles below are, while they're the same shape, they're not the same size. So the circles are congruent, but the triangles are not. All right, so matching or congruent polygons have matching congruent sides and matching congruent angles. When you're naming polygons, we talked about this the other day, that you need to have your ordering system in place. For example, the polygon on the left up here, this guy right here, looks like it's kind of been flipped over some vertical line and mirrored over into this polygon right here. So it's kind of like a reflection looking in the mirror. So when you're naming the congruent parts of the polygon, you have to make sure that you're matching up the corresponding parts. For example, this line segment AD would not be congruent to this line segment FG. You have to be really careful when you're putting stuff together. The line segment, let's go down here to the lower right, line segment, right here is where I'm at, line segment AB, so that's this guy right here, would have to be congruent. Now here's where the tricky part comes in. I have to go in the correct order. For example, I went from orange to blue, I went from low to high. I have to do the same order over here. So I have to say EF over here. All right, you might think it's a little picky, but when you have your AZ merit and your final exam come around, if you don't answer it in the exact correct order, the answer will be marked wrong. So you need to make sure that you're paying attention to the sequence of letters. All right, so AB was congruent to EF. CD, which is this guy, CD is going to be congruent to GH. This should be right in my line segments. C would be congruent to FG. DA congruent to HE. And then let's go over to angles. So angle A would be congruent to angle E. Angle C would be congruent to angle G. Angle B would be congruent to angle F. And angle D would be congruent to angle H. Okay, that one was pretty easy because they gave me an actual color-coded system. So don't be that easy because they're not. Okay, so when naming congruent figures, the order must correspond with the matching parts. So, for example, they are triangle S, TU. Okay? Notice that angle S is falling between the markings with, or the sides with markings of 2 tick marks and 3 tick marks. Over here, make sure that I choose the angle when I start, because that's where I need to start. That is between the second, or the side that has the 2 tick marks and the 3 tick marks, which would be angle V. So I'm going to start with angle V. I'm going to follow the same pattern that they did here, ST. So if I'm going from S, I'm going down the side that has the 2 tick marks. Over here, over on this side, I'm also going to go down the side with the 2 tick marks. And then I'm just going to follow along, so that once you get your starting point, it's pretty much done after that. So I went from V to X to W. All right, congruence, YZ. Here we go. Y, Z, A would be congruent to Y, B, A. And then finally on the right, triangle CDE. Oops, hold on a second. I lost my pen there. Okay. CDE, CDE. So I started at the top and went to the right angle and then went to the shorter leg. So I would name that one FGH. All right, so this one says, if triangle WIS is congruent to triangle MKV, what are the corresponding or congruent corresponding parts? Well, your life's going to be a whole lot easier if you just draw yourself an image. So this triangle WYS. So it really doesn't matter what shape your triangle is, but the important thing is congruent. You want to make the second triangle, try and make it look as similar to the first one as possible. So WYS, I went WYS, so this one has to go MKV in that same order. So MKV. Now it's going to be easy for me to identify the corresponding parts. Line segment WY, which is this, has to be congruent to line segment MK. Line segment YS, which is this guy, has to be congruent to KV. And WS has to be congruent to MV. Moon Valley. Yay, go Rockets! All right, angles. Angle W to angle M. Angle Y is congruent to angle K. And finally, angle S is congruent to angle V. Okay, so once you get your triangles drawn, it's a pretty simple process. Suppose that triangle WYS is congruent to triangle MKV. All right, let's talk about that for just a second, because looking at these two triangles, they don't look congruent to me. So what has happened is this is what's going to happen a lot in geometry. Sometimes things will be reflected, so you'll have a mirror image. Sometimes they'll be rotated. Sometimes there'll be a combination of reflecting and rotating. So you need to train your eye how to identify what's going on. The easiest thing that I have found to do is, if I'm given the two triangles are congruent, if I know that the triangles are congruent, I don't really want to look at this guy, because that is really confusing to me on how I'm going to label that if the thing has been reflected or rotated. But I know that if I create a triangle that is congruent to WYS and make it MKV, my life will be a lot easier. So what I'm going to do is I'm going to take this triangle right here and I'm going to try and duplicate it as best I can. So I'm going to do this, and then I've got a straight line, and then I've got a line at a little bit of an angle here. So it doesn't have to be perfect, but you get the idea. So on this triangle, I go W, let's go back up. I'm looking at what's at the top of the page here, WYS. So if I go WYS, then I have to go MKV. K, B, because that's the order of this triangle up here, right here. All right, so now I'm going to transfer the information that I know. Since the triangles are congruent, if this angle here is 35, then this angle also has to be 35. My board's got a hot spot today. If this angle is 62, then this one is also 62. And it's asking me for angle B. Well, now I can just apply my properties of triangles where I know all the angles add up to 180. That's going to give me 180 minus 98. Those turn into negative 98. So the angle here has to be 82. Okay, so drawing your own triangle in a sequence that is given to you up here at the top can be really helpful when you're trying to match up congruent parts. Third angle theorem, this goes in your notes. If two angles of one triangle are congruent, then the third angles are also congruent. What that's saying is if I have a triangle where this angle and this angle are congruent, and angle B and angle E are congruent, then by default and by the 180-degree property, that these two angles here have to add up to 180, or let me take that back. All triangles have to add up to 180, so if two of them are known, I can figure out the measure of the third angle. So if these two are congruent and these two are congruent, then the third angles also have to be congruent. I should use a third marking tool. Okay, so that's basically third angle. Example 3 says triangle ABC and triangle AB or DEF above. I'm using those triangles to find the measure of the missing angles. The measure of angle A is 74. Then the measure of angle D also has to be 74. I guess this should have said that these are, oh no, the angles were marked similar. Never mind. Just kidding. Okay, so these angles, angle B and angle E, have the same marking. So that means that they are congruent. Therefore, if angle B is 44, then angle E also has to be 44. And if a measure of angle C is 62, then the measure of angle F also has to be 62. Find the value of the variable truth if triangle P is congruent to triangle FJH. So here is where I like to draw my congruent triangle, because sometimes it's easier to identify your congruent parts. Some of you won't need to do that. Some of you will have a keen eye and you'll be able to just identify the identical parts without the third triangle. But I think it's in a good habit, especially at the beginning of geometry, until you have trained your eye to draw that other triangle, the congruent triangle. So I'm going to try and match this triangle right here, the size and shape of it. So I am going to go down like this, and then like this, and then something like that. Pretty close, not exact, but that's okay. So my top angle is angle F. My angle over here is going to be angle H, and this one is going to be J. All right, now I'm going to transfer all of the information that's in this triangle right here into my newly drawn triangle. So the measure of angle F is x degrees here, so it's going to be x degrees here. And the measure of angle J is y degrees. And the measure of angle H is z degrees. And then JH is C, so this is going to be C. FJ is A, so that will be A. And FH, which is this segment right here, is B. Now look how nice and neat those things are going to line up. All right, so I can find over here, number 5, I can find A, which matches up to 12. I can find B. B is right here, which matches up to 15. And then C is going to be 10. All right, X, now we're talking about angles. So X is going to be the same as this angle, which is 40 degrees. Y is going to be the same as this angle, which is 105. And then Z would be the remaining angle, which is 35 degrees. What is the value of X? So here's where you're going to use that training your eye system to figure out what information can I pull out of these two triangles. Well, I can see some markings on the inside of the triangles that are telling me that some angles are congruent. So, for example, this single marking here means that it's congruent to this singly marked angle there. This doubly marked angle is congruent to this doubly marked angle here. That tells me that because those two angles are congruent, my third angle theorem says then the third angles must be congruent. All right, so that tells me now that 55 degrees is equal to my algebraic expression over here, which is 5x plus 5. I'm going to go ahead and distribute it, or I'm sorry, 5 times quantity 3x plus 5. I'm going to distribute that before I write it. So 15x plus 25. Then you could go ahead and solve for x, and I think x is equal to 2. Okay, what is the value of x? All right, so what can we pull out of the diagram that's already there? Clearly, these two angles are congruent. I'm going to go ahead and say that I know these angles are congruent also because of vertical angle theorem. So if these two angles are congruent and that other angle is congruent, then by default, this third angle has to be congruent, which means if this angle is 65, then this angle has to also be 65 degrees. All right, given triangle WXY is congruent to MNO. So here's an example of where it gets kind of confusing when you're trying to figure out which angle goes with what. So instead of looking at this diagram right here, I'm going to duplicate this one and then use this lettering sequencing to transfer my information. All right, let's see what that looks like. So I'm going to try and duplicate my first triangle. So I got something that goes down like this, then I have something that goes across like that, and then I got something that meets up with it over here someplace. So again, clearly not congruent, but I'm just doing the best I can with what I got. So my triangle here goes WXY, WXY. So my MNO has to go MNO. All right, so I'm going to just now transfer what I know. I know that this angle's 38, so I'm going to already put that there. That angle's 38. And I know that angle M from this diagram is 74, so I'm going to transfer that up here, 74. And then I know that angle O from this diagram is 7a minus 4. Oh, look at that. So I have 7a minus 4 in one triangle, and then in other ones told me it has to equal 38. So that's going to be how I'm going to solve for a. 7a minus 4 has to equal 38. And I think when you end up solving, a is going to be equal to 6. If I add 4 to both sides, that gives me 42. And 42 divided by 7 is 6. All right, so I've already solved for a. That was one of the things I was supposed to solve for. Next I need to solve for b. So I know that this angle here is 4b plus 8. So I guess there's a couple of ways that you could go about this. I think probably the easiest way is to know that the three angles here have to add up to, oops, back that up. The three angles there have to add up to 180 degrees. So let's do that. This one and this one and this one have to add up to 180. So 74 plus 38 plus 4b plus 8 have to equal 180. And then you could combine like terms and solve for b. And if you did everything correctly, b should end up being 15, which you could then plug back in and find out what the measure of the missing angle is. All right, find the measure. If RST is congruent to XYZ, find the value of N. All right, so again, I'm going to draw my congruent triangle. RST, RST. I need a congruent triangle in this order, X, Y, Z, so X, Y, Z. And I know that angle R is 40, so X has to be 40. I know that S is 50, so Y has to be 50. I know T is 90, so Z has to be 90. I'm trying to figure out what this is. So that's going to have to be equal to 50. 2n plus 10 is equal to 50. And then if you solve, looks like I'm going to subtract 10 and then divide by 2, so n is going to be 20. All right, RQP is congruent to ON. All right, here we go. Okay, RQP ONM. That means this is 70. That means these two are the same measure, which means NM over here is 3x minus 5, which down here I have 3x minus 5. So I know that this side length right here is equal to 70. It's also equal to 3x minus 5, so that's my equation. And you could go ahead and solve for x from there. All right, I'm going to go ahead and stop there. Have a nice weekend, and we'll see you Monday.